So without further ado, I just give the microphone to one of my favorite crazy professors, Ian.
Wow, what an introduction. Huh? Yeah, I see that it doesn't work. Yeah. Good afternoon, everyone. Normally I have some slides about me, but I have so much I want to talk about, I'll make them very brief. I'm kind of the accidental professor, I realize, because I'm not from academia, but I do have a professorship and a PhD somehow. And I hated school and couldn't wait to leave. School days, the best days of your life, or wrong in my case. And I went straight into business, into technology. I had a series of startups. In the 90s, I was working in the States building really complex distributed simulation systems for people like the Defense Department and aerospace people and NASA, and in those days we were using things like $50,000 silicon graphic machines, which are about equivalent to an i3 and a 1080 today. So I cut my teeth on real-time stuff where there were huge budgets, and now you can do all those things with much smaller budgets and a lot better. In the 90s, I also first tried retinal projection, which was a laser shined into my eye, which is where I got the bug for VR and AR. And I was living in California during the first or possibly the second wave of VR, because it's not new, it's just got better and cheaper, which is why we're doing things there. So that's a bit about me. Right now, amongst other things, I have an arts practice where I build network performance projects, working with orchestras and theatre companies around the world. And most of my focus the last 3 years has been in a professorship at Design Academy Eindhoven, which is just down the road here, where we have built 2.5 years ago the Trans Realities Lab, which is equipped as kind of a mashup space between games, XR, virtual production, live performance, low latency networking technology, and kind of a mashup between edge, fog, and distributed computing. So we're in a design academy where there are only 2 professors. The other professor is social justice, so I'm the only tech professor there, and we've built a really interesting team. And we've had several EU projects, one of which is at the core of what I'm going to talk about today, which was partly funded by my friends here, Volker from the European Media and Immersion Lab, which was funded by Horizon Europe, which allowed us to create the software, which allowed us to make the film we're going to talk about today. I also realized the term virtual production because it says distributed virtual production, but it's really distributed virtual production or distributed virtual immersive production, because there are no LED walls harmed or used in the making of this project. It doesn't mean that we can't work with LED walls, we just chose not to, because if you work in purely virtual production, yes, it means you work with metahumans, but the stage is an unlimited size. So I will move on. I'm going to show you a short clip first and then explain what that is.
We're recording? Everything's running? Hello, Anton. You hear me? Please go on this calibration spot there. Good. I'll go here. So, hello people of Oxford. Today I introduce to you my mother, Georgine Schrödinger. She's a really kind person. I love her very much. And but she used to be hard on me in my childhood because I killed her cat. So, Georgine, could you please go forward to the middle of the stage?
I'm going to pause that because it's quite a long clip. So just to explain what's happening here, and yeah, the mocap is terrible, don't worry about that. That wasn't the point of this test at all. This is Erwin Schrödinger, and I'll tell you why we have Erwin Schrödinger there, and this is his mother, Georgina Schrödinger, which is played actually in this test by Anton Gavrilov, who is, he's over there, he's a BOAS alumnus as well. He looks great in heels, I think. And the other, Erwin Schrödinger, is played by Andreas Dahn, who is actually an alumnus and a co-worker of Volker's over there who spoke earlier. So what we're seeing here is a physical film of Studio Aalto in Finland, who we collaborated with on this test. And Georgina, the mother of Erwin, is actually in my lab, Trans Realities Lab in Eindhoven. So what we have here is a multi-instance Unreal setup connected in real time. Both actors In some points are either wearing headsets or not, but the mocap data is sent between the different instances, and so they are acting inside the same virtual set, immersive world, even though they are 1,000 kilometers apart. So I'm going to move on to how we got to this, and then I'll show you some of the final clips and how we actually did that production. And I'm hoping, yeah, okay. Yeah. So in 2022, just after we were setting things up in Eindhoven, and I have a background in doing low latency performances between spaces, I explained. We wanted to test how easy it was to connect instances of Unreal and Unity, or both, or dissimilar games engines across large distances, and import things from one engine to the other for collaboration. So we did a research festival. We built a temporary LED wall in here, and we did a number of experiments over 2 days. We worked with ZRD Car in Zurich, who have a really nice interactive virtual production type set. The Swiss have a lot of money, more than the Germans, I would say, even, and especially the Dutch. We also did a test with the Interactive Architecture School at the Bartlett at UAL in London. And in each of these tests, we did things like taking a real-time camera stream from one engine at one location, streaming it to another engine, rendering it as a 2D texture, some volumetric stuff with CWI, that's like the Fraunhofer is doing volumetric streaming research. And then the last test here, some of you may know the guy on the right. He's Matthias Wittmann. He's a German fellow to some of you. I think Volker knows him. And he works at Digital Domain. And the guy on the left is actually an AI character in Digital Domain's custom render pipeline. And both of them were actually in Hollywood, and we were live streaming them into an Unreal instance in Eindhoven. So what did we learn from this? That it's very hard to break through all the firewalls, to do low latency streaming, to get motion capture between different engines over a distance, and we wanted to do a lot more research in this area. So my core research is about how we build distributed, interactive, immersive environments. And by immersive, I don't just mean headsets. It can also be LED wall, rear projection, tablet, phone, and so on. But obviously, headset is perhaps the highest level of technologically mediated immersion. So, and the key thing that was stopping us in testing this was things like networks, the complexity of setting up different systems. You know, any of you guys have done virtual production know that you always end up having a network tech there, you know, a low-level software guy, and so on. So we wanted to get a lot of those issues out the way so we could more easily build test beds to test future scenarios for distributed collaboration. So this is the lab just after we set it up. I think that's always 2023. And it's got a bit tidier and a bit more equipped. Since then, we have about 500 square meters of lab space. We're a bit limited on height, but just 4 meters. And we did a test which was partly funded by SURF. SURF is the Dutch NREN. If you don't know what an NREN is, the NREN is the National Regional Educational Network, or Research and Education Network. Each country in Europe and even in the States and South America has them, and they provide the internet to universities. The great thing is they tend to have really high quality, better low latency networks that we can even book point-to-point space on. So working between universities is a great way to test low latency systems, except that the IT department at any university will block everything because yeah, they're really worried. They're told by no porn, no DNS attacks, no students doing anything wrong, so lock everything down. Let's be innovative with our networks, but lock everything down. So that's the reality we live with. So one of the other challenges of what we wanted to do was to create a platform where we could get through a lot of those ICT issues to work collaboratively at a distance. So this project was another research project which taught us more about those problems. We had funding from SURF, and we did a simple test for a national XR event at TU Delft, who collaborated with us. We built a maze. We had people in XSEN suits, one in my lab, one in this space in Delft, and basically they were both real-time metahumans, and they were trying to collaborate working in a simple maze. And the test kind of worked, but it took 2 days at TU Delft to make it work. So that was the major roadblock to being more iterative and doing things quicker. And you can see there was another LED wall upstairs where you could see a low latency video stream from our lab, the stream from downstairs, and the two actors working together. So now I want to get into the software platform that we've built with $500,000 of funding over the last 15 months from Emil and Horizon Europe, and then talk about the film that we've just made weeks ago using that platform over multiple locations. So the idea of the platform is basically that it can support the creation of high fidelity, you can read this, real-time networked XR. Networked XR you can read as metaverse, spatial web, intraverse. We're using, or I'm using the term intraverse because I think there may be a set of standards for a metaverse, whatever that is, but there will be many implementations of that, just like we have intranets today. There will be closed user metaverses, even if they're built on standards. So we're building a platform that allows us to prototype the future using the best-of-breed components. So rather than Microsoft Mesh or Facebook Horizons, all these horrible low-poly, legless things that are no fun unless you want to do a double glazing, sales, pizza party on a Friday internationally or something. For real world applications, whether it's industrial, metaverse, media, content production, you need better things. So that's what the toolkit's about. Can you keep a track of me on time? Because there's a lot I want to go through. So if it's like halfway through, give me a shout. Thanks. It is. Oh, Jesus. Okay. And I'm going fast. So I can go through more. We have a demo space here, so we can show you some of this over in the marketplace. But basically, these are, just imagine you have two labs that are doing like virtual production. And over here, you have like a games engine, systems, HMDs, a mobile, rig metahumans. You have another lab over here. How can you connect those two together so they can act as one virtual stage or one virtually collocated production environment? As we said, you have firewalls, networks, you don't know what the assets are, everything is on different subnets. There's huge networking and logistical problems in doing that. So what XRIT does is to provide a server, which you can have many copies of, which is called an orchestrator, a front end, which is a web-based GUI, so you can access it from anywhere with the right privileges to communicate. We have a client that is already integrated, I think the next slide shows that better, a number of different mocap systems and components that are typical in the type of research we do, but also very typical in virtual production, and basically makes it all to work together seamlessly. I think, this slide, okay. So at the moment, after 15 months, we have built a client which works with Unreal, with Unity, with Xsense, with OptiTrack Motive, with HTC Mars Vive, and also plugins, specific plugins for Unreal Engine and Unity that automate a lot of tasks based on just simple functions you do in a drag and drop interface. And we've also integrated a product from the Czech MREN, like Surf, which is a really great software product been using for 20 years, open source, that allows us to do low latency audio and video streams. So as well as doing collaborating in virtual space, you can also get all the back channel communication, get camera views into different physical spaces. That's a simple part of the user interface. I think this is already 3 months old, where you can configure systems that you want. This shows you, in the case, I think part of the test we made, this shows you different computers, what functions they're running, whether they're running an instance of Unreal Engine or OptiTrack, MVN, and they show you in the different labs that they are in. And then this drag and drop interface, which is much better to show you in the marketplace. But just as an example, if you go to an instance of OptiTrack, which can be running in any lab that's running in XRIT, it doesn't have to be in the same lab on the same network, because we build a self-healing VPN between all the labs. You just drag a line from the output of OptiTrack to Unreal. And what that one line does is automate the setup of a new stream in OptiTrack without having to touch OptiTrack. It instantiates the OptiTrack plugin in Unreal and correctly configures it to receive that stream from OptiTrack. It also will then go and, unless you've unticked it, it will actually set up a default rig character and target the OptiTrack data to that rig. So stuff that normally takes a network guy, an OptiTrack guy, an Unreal guy, is done through drawing one line on the screen. So we see actually, as we add more things to this, applications for using this just even in virtual production facilities which are not networked in standalone places. And we already started to test that with Auto in Finland. We also, this is not the final GUI, but this gives you an idea of the Unreal plugin. So one of the problems you have when you're working in different physical spaces but co-located in a common virtual space is that I might be in Eindhoven facing this way and I'm in Finland over here facing this way, but we both want to be in the same space. So we have a plugin which works across all the instances of Unreal in a setup, which allows us to spatially co-locate and orientate actors within the space. And we also have a bunch of other things, which I won't go into now, like tools which align headsets with motion capture suits, so you don't get heads which are offset from suits when you're navigating around in a virtual set. So now I just want to get into the film that we made 3 weeks ago, which is a test case, a distributed virtual production test case for XRIT. And spooky action at distance. This is this idea from Einstein. You've heard of it as quantum entanglement, the idea that two photons born in the same place in different locations somehow interact. So we thought that was a fun, appropriate thing to make a film about, high energy physics, why not? But also because it's the International Year of the Quantum. And I like high energy physics. So we've made this film called Cat Content, which is will be a short 10-minute film where Erwin Schrödinger starts in Oxford University, travels to see his mother who's dying, ends up at the wrong hospital, and then ends up back in Oxford still seeing his mother in the room. But it becomes more obvious when you see the film, and if you're a quantum, you will get all the jokes in that. So how do we actually do this? How long do I have? 8 minutes. Oh, okay. So I think this is a bit technical. Basically, we had 4 locations, including Film Academy and another studio in Auto. But in the main locations, we have multiple instances of Unreal running in each location. Each of those is running our client and our plugin. And I think most of you will know why we're running multiple instances. Time you add additional render output, your frame rate drops, and we're running really high end. Basically, each actor or director is in their own instance of Unreal. The virtual cameraman is in Unreal, and the same with the actors and directors at the other end. But they're all running the same scene that's pulled down from Git that we were using in this case, and they're all synchronized through XRIT, so that when you change something in one scene, all the others change. When you step to a different scene from the director's station, all the other instances also step lock on that. And again, they're all spatially connected, so they all track cameras and mocap data. But the key thing is we only really have to send control and command data, monitoring data, and mocap data between these. We don't need things like volumetric screening or complex telepresence. The data feeds are relatively low, and they're running through VPN, so they get through all the firewalls. And then we have interfaces that also go into into the headsets, so the actor, director, and so on, each could see each other in the virtual environment as metahumans in real time, even though they're in different locations. One last thing to mention, we also use GPS time, so that when we're filming, even if we film in different places, everything is time code synchronized. So that's something that you don't typically see in a virtual production space. It's more technology that's coming from from the broadcast industry. That one-third or complexity that the other diagram hides behind XRIT. Just because this is not specifically visual production, but I wanted to tell you a bit about the visual development process. At the top end, we have our visual guys worked scene blocking in Unreal. They used external assets from Quixel, from Megascans, a lot of asset creation in 3ds Max, reprocessing of those assets in Houdini, and then as I said, a couple of them are over there. They developed a brush process to give this painterly effect. So the actual sets look photorealistic. Oxford University in the actual set looks photorealistic, but they applied this painterly brush effect to all of the scenes and the characters. And then lighting, texturing, procedural content generation, and asset animation were done in Unreal. And you can see an example of blocking of a corridor in the university in one of the scenes. There you see it after it's textured with the painter brush approach. Here's an asset from 3ds Max. There's a train with the two characters in different locations traveling together on the same train in the film. And there's the effect applied to that. I think that's just some stuff in Houdini. This is showing procedural content generation. Probably a lot of you are familiar with that. So this isn't automated by XRIT. It's just the process that we went through to build the sets. In terms of character development, I think these are some of the earlier characters, but Schrödinger is as a man, he's also as a little boy. We just scaled him in mocap, and it actually worked quite well for that. And his mother and some nurses who were in the film. Process for that, relatively straightforward character creation in Character Creator 4. Brush process, the same as with the other assets, and then in Unreal. It's cat content, so we also have a rigged cat. And I just want to talk about the shooting, because that's, I think, the really important bit. So this is This is a scene leading up, I think, beginning of filming. We shot over 4 days, 2 days of technical and actor rehearsal, dress rehearsal if you like, and then 2 days of actual shooting to create what would be about a 7 to 8 minute final film, I think, over about 20 scenes. And if you wonder what she's doing there, perhaps it's obvious. Yes, she is stroking a cat. You still need physical props. And again, I'm going to jump through so we go quickly. In our lab at the Trans Realities Lab, we had director and scriptwriter Andreas Drahn and Dave Sagan, who's a German actor, because we wanted Austrian accents for this. We also, within XRIT, have this low latency streaming. So this is a 4K feed from Auto Uni coming into our lab, and we had a 4K stream going the other way, about 80 milliseconds between the two locations. And so there you could see live feeds from the other lab of what their physical and virtual cameras were showing. Here you can see a camera rig. So each of our camera rigs, there were 2 camera rigs in each location, and you can see that it's a physical view and a virtual view which are aligned. So we filmed everything virtually and physically. So as a complement to the film when it comes out, there would be a making of film where all of the physical views, so you'll be able to see like one actor in one space, but the virtual camera will show 2 actors in the same virtual space, whether it's filmed in Helsinki or in Eindhoven. And you see so the director and the actor are wearing headsets. The director's on a different level, so it doesn't show up in the camera normally. And he can see the scene with both actors in, even though the other actor is in Helsinki. And the actors can see each other, but not the director. I think there's some audio too. Okay. There's some audio of him reciting quantum entanglement as Erwin Schrödinger. And you can see we have displays on both walls. So one is showing the quadrant from Auto, and the other one shows our quadrant of local cameras and virtual cameras. And they had the same thing in Auto.
We are all made of particles.
Okay.
Let's rehearse.
I'm going to jump through as we have time, so you get a better view of that. You can see in this one, in fact, the headset's just there without the character. This is Anton was doing the calibration, spatial calibration between locations. Everything is recorded automatically with timecode, so all of the virtual and physical cameras, but also all of the mocap data and the camera position data. So we can actually recreate any scene if we want to across both locations because everything is time aligned. And here's a short clip. Yeah. So now you get a bit. Yes, I know she's out of focus at one point. So forgive us for that. Can we have audio possibly? Or?
Schrödinger, it's urgent.
No.
I'm sorry.
I don't hear it.
There is no one named Schrödinger in our hospital.
So
Listen.
Here you can see this is the live virtual camera shot. Here's David in Eindhoven, and here's Georgina.
My mother said she is in the hospital in Grünbach.
In Auto.
So here I am.
Well, there's also another place called Grünbach in Upper Austria. You sure you are in the right place?
And that's a fairly simple. As I said, there's scenes where they're traveling on a ship together, on a train together, and depending on if we get accepted to SIGGRAPH, if we don't, then we show it earlier. Otherwise, we're holding the film for SIGGRAPH, the show in Vancouver. So just quick lessons learned. The platform worked flawlessly. We had completely reliable streams, mocap data, audio, video streams, everything. Main problems, as always in this world, is with HMDs because of closed systems and crappy software. We've talked to Meta and all these people. They just don't want to open up things to more automation or APIs because it's not. They don't see hundreds of thousands of headsets as a market. They see millions of headsets as a market, and they're blind to enabling that. Had to manually rebuild facial capture software in the Quest Pro that we used, and we had issues with the audio to HMD head-mounted display pipeline. I have to say, OptiTrack worked with us, but we think OptiTrack software is it's not as great as it could be. Plugins just crash if they're not correctly configured, and some other stuff we didn't like too much. And we see a need in our platform for integration of back-channel audio systems so that tech teams on either side can talk. We can integrate with their existing crew systems. So we're working on that. I think I have just one more slide. What are we doing next? We're building into the platform local virtual bridges to further reduce latencies within the whole network, because latency, I think as someone said earlier, is really critical. You know, lower the latency, the further apart you can do these types of projects. We're adding a kind of a UDP OSC pipeline, so you can bolt on your own applications at either end and also put physical interfaces in. We are adding a native plugin for Unreal to do low latency streaming, so no having to muck around with NDI or Spout or Siphon or those things, or NDI, which will be controlled through XRIT. We just started a project building on this platform using AI for sensor fusion. So we're fusing spoken word and gestures for real-time co-navigation in distributed virtual worlds and scene building. So that's just starting now. We should have a prototype in the summer. And we have a series of projects in the pipeline linking educational locations for new pedagogical formats in immersive space. We have a live performing arts project. We're doing some metaverse, industrial stuff, and we're open for collaboration on Dutch and EU programs around virtual worlds where this can be useful. I think I'm there. Just the credits page, very important. So that's a shot of the people in Finland and the people in our lab at the end, and there we go.